Hello there, I'm Mr. Math Guy, and today we're going to take a look at a 10-minute video on volume of prisms. Previously on volumes, we have looked at the volume of a cube, which is V equals E cubed, where E is just the edge of the cube, and on a cube all the edges are the same. Then we also took a look at the volume of rectangular prisms, which the volume of that, volume again is how much can fit inside of a solid. So the volume was length times width times height. And today we're going to take a look at just prisms in general. All right. Now remember, a prism has the same base, top and bottom. Could be rectangular, could be triangular, could be a pentagon, and all the faces are rectangular. So if we had, for example, maybe a triangle, all right, triangular prism. It's kind of two triangles. These are the bases. We have here, here, back here. All right, so that's a prism, has two bases, and all the faces are made up of rectangles. All right, so what we want to do is figure out if we could put something, water or air or something inside of this, if there was a hole there and we could fill this up. Volume is how much material could we fit inside of that triangular prism. Well, the formula for any kind of prism then is going to be V is equal to capital B, and we'll explain that in a minute, times H. Now, this is kind of similar to over here. All right, we already talked about a rectangular prism, and what is the area of the base in a rectangle? Well, the area of a base in a rectangle is length times width, or base times height sometimes, but we just use LW. So what we talk about with this big B then is we're talking about the area of one of these bases. So in this particular one that I have drawn here, find the area of the triangle. Once you know the area of the triangle, then multiply that by the height. And when we talk about the height, we're talking about how long the prism is from here to here. All right. Now we're going to take a look at ones that might be slanted. Height is always perpendicular from top to bottom. All right, so perpendicular. So if you have like the Leaning Tower of Pisa, right? So I mean, I don't know if it's considered a cylinder or what's the top of it look like, but it looks something like this, right? It's slightly leaning, and so the height. What we're going to figure out, the height is from not from here to here, but our height is actually going to be from the top of it straight down. So it's perpendicular to its base. So make sure that we understand this H is a perpendicular. It's also referred to as maybe an altitude sometimes. So let's take a look at some examples of finding volume of prisms. All right, so this first one right here, again, we're going to see, it's a prism. So it's always good to write down your formula, capital B, H. Then we have to figure out the base. The base in this particular prism is an equilateral triangle. So going back to learning about area of an equilateral triangle is s squared times the square root of 3 all over 4. So since one of the sides is 3, then our area is going to be 3 squared, which is 9 square root of 3 over 4. So this would be the area of the base. So then our volume is 9 square root of 3 over 4 times the height. And the height's given to us, the length from one base to the other is 18. Now, we you could do this, do a little bit of canceling here. 2 goes into this one, 2 goes into this one, 9 times. So we're going to get 81 over the square root of 3 over 2 cubic units. So cubic units. Remember, volume is measured in cubic units. So this would be the volume, how much would fit inside of this triangular prism. In this particular triangular prism, we have V is equal to capital BH. And so, again, this base is a triangle. It's not an equilateral triangle, but it's a triangle nonetheless. So we're looking just at the triangle portion. So if you want to kind of split it up, you can. It looks something like this, all right? And they tell us from here to here, that would be the height is 9. They tell us this is this. So remember, the area of a triangle is 1/2 the base times the height. So the area of this triangle would be 1/2. The base is 12 times the height of this triangle is 9. So it would be 6 times 9, which is 54 square units. All right, so the area of this space is 54 square units. So V then is going to be the area of the base, which is 54. We don't need to put the square units, just 54, times the height. Now the height of this is given to us is right here. From base to base, it's 5. So it's 54 times 5. And 54 times 5 is 270 cubic units. 270 cubic units. In this particular prism, it's a regular pentagonal prism, which means all the sides are the same length. So each side of the pentagon is 11.6. We know the height of this prism is 14. And this 8, well, that is called the apothem, which is going to be important for us because the volume of this is going to be equal to the base times the height. Well, the base, the area of this base of a regular is 1/2 AP, a regular polygon, where A is the apothem, which we know that to be 8. It was given to us, and P stands for the perimeter. So it's 11.6 times 5, and calculator would be easier here, but oh well. Be 30, carry the 3, and then so it'd be 58 is our perimeter. All right, so this is going to be 1/2 of 8 times 58, so that will be 58 times 4. Again, a calculator would be very handy when doing these calculations. So 232 is the area of the base. So volume is 232 times the height times 14, and I'm going to get my calculator for this particular calculation. And that is going to be 3,248 cubic units. All right. So the key for finding volume is you just really need to be really good at finding the area of the base and remembering your formulas for finding the area of the base, or at least looking them up and figuring it out and then multiplying it by the height. So the key again for finding volume of prisms would be to be really good at knowing how to find the area of a base. All right, here's a problem that an application problem might involve volume of prisms. We have this prism, let's say a concrete water trough or something, and let's say the dimensions of this are 24 by 48 by 96 inches long. So it's 2 feet by 4 feet by 8 feet long. All right, it's a concrete water trough, and we want to know how many gallons of water could we dump inside of this water trough. Well, if we know that 1 gallon is equal to approximately 231 cubic inches, then what we need to do is figure out the area of this. So the area is going to be just the area of the base times the height, and since this is a rectangular one, it's just length times width times the height of it. And so multiply those together and we get a volume of 110,592 cubic inches. Now, that's not the answer. That's just the volume of this water trough. If a gallon contains 231 cubic inches, what we need to do is take that number and divide it by 231, and it gives us approximately 478.75 when I round to the nearest hundredth. All right, so approximately, if we just round it up, 479 gallons of water would fit in this 24 by 48 by 96 inch water trough. All right, so again, volume, the key for finding volume is just knowing your area formulas, area of your base, and being able to calculate that, and then just multiplying it by the height. And again, the height is from one base to another base at a right angle. It has to form a right angle. So if any kind of a prism is slanted, make sure you know the altitude, not just the slant height. And so that's how you find the volume of prisms. God bless.